So let's look at our agenda, what we'll be talking about. First, why we even talk about modularization, like why actually we want to modularize, why it's important, why we keep talking about it for many years already. It's not a new topic. Then we will explain what actually we mean by module graph, because we'll be talking about module graph almost all the time. Then we will introduce something called module rules on top of the module graph, like it will somehow help us to organize the graph and get actually the benefits. This is at the end why we are here. And we will measure. Like we will measure how to improve the graph, how to improve the build times, how to get the benefits, like why we are actually modularizing. Then I will try to share like some of the common traps, like what are the usual pitfalls with modularization, what typically makes your module graph wrong, and what kind of removes the real benefits of the modularization. And then the last thing, I will try to talk about business impact, because modularization is quite often treated just as engineering. But at the end, we are doing it for a reason. Like we are trying to enable like a better product. We are trying to deliver faster. So it's really useful if you kind of try to share this with your leadership and say, okay, we really want to spend time on this because we find it useful. Like we want to do better things for our users at the end. So why? Why we actually want to modularize? There is many reasons. Some of them is scalability. We want to scale our app. We have many engineers. We want to scale. We have build times. Build times are getting slower as our app is getting bigger. Then we have collaborations, like we don't want engineers to step on each other's toes, so we want to split the app into smaller pieces, which their teams can autonomously collaborate. Ownership, this is also very important, so like we want to be able to teams to separate their features and be able to autonomously own them, maintain them, and again, not steps on each other's toes. Reusability, so this is another important thing. You want to encapsulate in a module some functionality, so this is why you would like to modularize as well. And possibly dynamic delivery or instant apps. They are basically based on modularization. So if you want to do something like that, you will have to modularize. And architecture. Like this is on purpose as a last thing, because you can have the best architecture without modularization, but modularization can help you to actually achieve like better architecture. But it's not like a condition. You can have the best architecture without modularization. But also, why not? So you will always hear like, yeah, we all have to modularize, but there are many reasons why actually not to modularize. Everyone is modularizing. I can imagine most people here probably seen some app which is modularized. It's not like a real reason, because quite often you can start like over-modularizing without scalability issues. Like if you don't have them, maybe you actually don't need to modularize. Like you hear articles and talks, yeah, let's modularize, we have to modularize, but there is a cost, it's not for free. Then you can over-modularize. You can have a very small app with 50 modules. You actually can get net negative benefits. So there is a risk that you will actually over-modularize. And then modularization is cool. Definitely it is, but still it shouldn't be a reason why to do modularization. And architecture. So at the same time is a reason why to modularize. Also, it might be a reason why not to modularize, just because of the sake of architecture. If you have a small app, might not be worth it, because I will show in many places like how the modularization has a cost. So let's talk about module graph, because we'll be like basing a lot of our metrics and everything on the module graph itself. So this is how everything starts. You have one module, everything is inside, everything is simple. We have just one app module. This is already a graph. It has one node, no dependencies. But we want to scale. We want to extract some features. So we have 3 features. One is users, another is analytics, and another one is config. These 3 features will go with us through the whole talk. Right now, they don't depend on each other, so everything is fine. We modularize, they build in parallel, teams can autonomously contribute. Everything is great. So this, we would be very happy with something like this. But they need to share code. Like they need to communicate somehow. You cannot just like, this is basically unrealistic. So we say we will have something like a core, or base, or like you can have many different names how to name such a module, but we want to share code, we build something. All the modules depend on that. So this is already starts being like a module graph. We have dependencies between each other. App depends on all 3 features. All these 3 features depend on core. And they are independent. Still, so far, so good. But then this happens. So users somehow want to depend on analytics. You want to measure your users. Analytics need to be somehow disabled or enabled or customized, so they depend on config. So suddenly, it's not so good anymore, because if you actually look at that graph, you are having a list. If you go down the red line, which is called longest path, actually this doesn't look like that from a code. You don't really see it because you have just Gradle modules. But this is a list, and at the end, monolith would be even better in this case, because everyone depends almost on everything. And also, if you collaborate between teams, the team which owns the config module is making changes for everyone. So this is why we actually talk about module graph, because we can quite easily see what is happening there. Well, easily. So The reality is like much more striking. So at the moment you have hundreds of modules. It's very difficult to navigate through it. So we need to do something better than just like drawing module graphs and like having something like that. So why we talk about module graph? It has direct impact on scalability. Like you can see which teams depend on each other, like who is independent, who depends on who. The build time impact, I will show into detail like how it actually impacts the build time, but the module graph is really like a direct connection with the build time. Then the team dependencies, you can see who depends on what. You can visualize it. So this is important. This is why we talk about module graph, because you can actually see, like you can reason about it, like you can show to your peers, like, okay, this is how our application actually looks like. You can generate it from the Gradle config and from Gradle in general, or even from different build systems. And it's measurable. So this is like the most important property of the module graph, because at the moment we start focusing on it, we can start measuring, we can start reason better which modules are good, which modules are not good, what to focus on. So let's talk a bit about build time, because it's maybe the best example like how we can show like how the modularization can be good or not really. So in theory, more modules means faster builds. But more modules means also more tasks, more Gradle tasks. More tasks means bigger build graph, and then modules have a cost. They are not for free. That means that more modules doesn't necessarily mean that we have faster builds. We've seen many cases where we had more modules, but the build actually got faster, slower. Sorry, I will show like a few examples. So then the task graph. So at the end, like when Gradle builds the app or any other build system, they build something like a task graph. Like all work in Gradle is a task. If you build Kotlin, it's a task. If you build resources, it's a task. If you assemble your APK, it's a task. So everything is wrapped as a task. Plugins add tasks, so you have Android plugin, you have Kotlin plugin, any plugin, they just add tasks. So this is everything in a Gradle is really a task. And Gradle, if it builds a task graph. And it starts resolving dependencies and like build and go up the graph. It can look something like that. So this is a very simplified version, but you can see assemble debug will build your APK. First, you need to build Kotlin or assets, and then to be able to build Kotlin, you need to process resources. So let's say how a good module graph looks like. So we see application, which will build for 2 seconds. We see feature users will build for 15 seconds, analytics 10, config 10 as well, and then core will build for 3 seconds. As you build, you will follow the red line. So you first build core, then you build all 3 modules in parallel, and then you build app. So you end up with 20 seconds build time. So this is great. Like this is something we would like to see everywhere. But it literally takes just like 2 lines of Gradle code. So you somehow need analytics. So you add just a project dependency, the same thing for config with analytics. And you suddenly have this, and you end up with 40 seconds. So this is how it behaves. Like basically, in the initial time, the feature users, analytics, and config, they build all in parallel. It takes very small change to just make it serial. You double the build time. You might not even notice because Gradle has some like ways of optimizations, but in general, like your build time will start growing. And again, like in a more complex graph, you see it even less clear. So let's talk about something module rules. So now we have a module graph. Let's build on top of that some rules based on which we will start doing some metrics. So modules will have a type. Type is like a simple attribute. We will somehow just classify modules by some types. Like if you talk, there's many different talks about modularization from different companies. Typically, there is some classification of a module. It can be really anything, like type. It can be a feature. It can be implementation, something like that. You define rules, like how these modules can depend on each other, and you can enforce it. Like at the moment you do something like this, you can actually create some measurements and some enforcement to actually make sure that these rules are followed. And that's the key thing. They are measurable. So even when we have something very crazy, like a crazy module graph, we actually can start reasoning about it and make it better. So these are module rules we used in several projects we did, but let me just explain a bit. So the typical module type is app. This is like typically there is one or you have multiple, depends on your projects. But then we have, let's say, 2 or 3 layers, which are called, in this case, implementation. Then there is an API, and then there is something called shared types. The naming is not that important. It's more kind of the notion that the same types cannot depend on each other. You can see the red crosses. Basically, it means like implementation module cannot depend on implementation. You can really think about like a feature. What is also important, like it doesn't need to have a UI API or anything. Like that's kind of irrelevant when it comes to modularization. What is important is like these modules don't depend on each other. The same case comes to an API, and the same case comes to a share type. In theory, you might need just an API, but the share type is there because typically you kind of need to migrate a legacy app, so it's kind of like a helper which will help you to progress faster. But really, like the main thing to remember is like implementation modules cannot depend on each other. API modules cannot depend on each other. The API module is a way how to share code between modules. You can also see like sometimes people call it public, sometimes people call it interface or contract. Like it's a very common concept. The key thing here is these modules cannot depend within a layer. So how it looks with the module graph. So like we have an app, this is at the top level. Right now we have like this kind of bad module graph. Like these modules are implementation modules, but they shouldn't really depend on each other. So we again have 40 seconds built. So how we can improve that, like using the module rules we just shown. So we would like to decouple feature analytics and feature config. So what we can do, we can create a config API. So typically, like the feature analytics will use like a very small part, like only some interface or data class or something like that from feature config. You can extract it into a very small module, which will, in this case, build for 1 second, but like you can imagine, like it can be even faster. Basically, the minimal public interface. So when you, as a team which owns a config, when you would like to basically use this feature, you are extracting only a minor API, which builds very fast. So then it's already better. So we are at 30 seconds because we kind of like removed that dependency of analytics and config. So, but we can do even better. So we can do the same for the analytics. So with the same technique applied once more, we wanted to break the dependency of users and analytics. We just created analytics API minimal as possible, and then we just depend on that interface. Then we can somehow compose things together within the app module, like typically Dagger or another dependency injection will help you with that. But we can go even further. So right now we are at 20 seconds. We are where we started. So this is already good. But we can go even better because there is this kind of thing like core. Core can have an API as well. And I want to emphasize that because typically people think about core or base, however you name it, like about something special. When it comes to modularization, it's not really special. It's just another piece of code. It's just another feature or implementation, which can have public API. So like that, the core can be way bigger. Right now we have it as a 3-second size, but it can grow massively. Having an API for it might help you, and it kind of like removes the discussion, what is the feature, what is the core. From the modularization perspective, it doesn't really matter. Like, yeah, so this module graph already starts being a bit more complex, but it's flat. Like the flatness is something I will try to emphasize. This is what we care about. We want to have a flat graph. So we got 18 seconds built. We got even better. But still, reality is still like much more difficult, so we need to do better. So what we can do is like at the moment we define module rules within your team, like it's really up to you, like what you agree on. We can, for example, implement a Gradle plugin, and there is also an existing one, which I will be sharing with my references. You can set the module types, you can define some DSL, or you can just define some property. And you can fail build on a violation. Like this is like the important thing, which kind of proved to us always to be crucial, because if we didn't do that, engineers just don't see that. Like you don't see that graph when you're working. You just need to have a dependency. You need to progress with your task. So you just bring another module as a dependency. Why not? This kind of assertion will prevent you from doing mistakes, and typically you can kind of link to documentation. And you should run it on every build. Like basically at the end, what it's doing, it's comparing dependency of modules. It literally takes a few milliseconds, so the overhead of that is not significant. There is an existing plugin, which I will be referencing in references, but you can build something very similar by yourself, because at the end, it's just iterating through Gradle dependencies. So at the end, what we are after is we got some error message. It's like this module, sorry, cannot depend on this one. Ideally, a link to documentation. This is how you should solve it. In our case, create an API module or use an API module if it's there. So this is how you can kind of scale it across many teams, because the teams might not be aware of all the strategy. Ideally, of course, you try to share as much as possible, but this basically will prevent your mistakes. So let's go to metrics, because right now we set up like, okay, so what is a module graph? We have some rules on top of that, and like how to actually see that we are getting better. So what we can measure. We can measure, okay, so we have that much code migrated into this module type. We know that this module type is better than another one. We know that some modules are not yet migrated because there are some restrictions. So we can measure the adoption, actually. We can also measure the height of the module graph. I'll be sharing all the definitions. We are coming a bit to the graph theory, but it can be a good indicator where to actually start, like how to start improving your module graph, how to start getting the benefits of modularization. The longest path, something very similar. It will be always in a graph I'm showing is the red line. It's basically the longest way from the app to the module, which is as much as far away as possible. And you can also measure dependencies between modules. Like if some of you have open Android Studio, I'll very shortly show how to do that. And then something called between centrality. I will just mention that because this is something quite interesting from the graph theory. You can use some software to calculate it for you, but this can mark in your big module graph like the bad modules. Like we will be talking about which modules are actually bad, which ones we don't like. So let's see example of the metric. So this is something we basically introduced, like we started saying, okay, so we want to have all our modules to fill in the standards. So you can see like how it's kind of like evolving, getting better. It serves really well as an indicator of progress, but also as a motivation. So if you want to move to some structure which you like, it doesn't necessarily need to be this one. It can be really anything you agree with your team. It's really useful to have a metric because as there are many teams which are contributing, you will see if you are getting better or worse. Because we also seen sometimes the metric went down and then we start saying, okay, so what happened? It can give you the feedback loop. It's like, okay, this situation, we don't have it documented. We don't know how to solve this problem. So it can kind of tell you, okay, these are the problems with our strategy. And similarly, you can see like how the code, for example, from the app module is getting down. At the end, is using the same metric. This is from Datadog, but it doesn't really matter. Whatever analytics you are doing, you can just like periodically dump some like metric into that, and it will significantly like help you to see how you are actually doing. Module height. So this is like a useful indicator if you want to see like how your module graph, how healthy it is, how good it is. Ideally, the flat one is the better one, so lower height is better. In this case, what we have here, so the app is at the very top. It needs to go through 4 modules to get to the core, basically, along the red line. Of course, it can get there faster, but the height is associated with the longest path. So you see the red line, basically, to get to the core. You need to go through users, analytics, config, and then core. So what you can try to do is somehow like reduce that height. If you do that, it like highly correlates with the build time. Like typically when you run your build, you will see like the same modules are kind of on the longest gradle path, how they build based on the height. And the longest path is basically the same. Like it's the red line which kind of connects like the longest path through the modules. Like you can use it as an indicator of progress. What we did was every time you kind of try to break it, and then you will have a new longest path because the longest path is always there. So like the way how we were trying to tackle the complex graph was like, okay, what is on the longest path? What we can break? Let's do it. After it, what is the next longest path? And then you can continue like that, and you can iteratively end up with something which is very flat, which is what we are after. Dependencies between modules. So the core is quite often mentioned, or a shared module, or base, however you name it. It's very common to have a bad core. What does it mean? It's like we have 2 features, users and config, and they share some code. But actually, if you start like measuring, you will see that 50% of the core is used only within users, but still config needs to wait for everything to compile. It depends on everything. And 40% is used only in config, and then 10% is truly shared. So this is also like a very common scenario where you like share code, but you are oversharing, and then your modules like depend on too much. So there is a way how to measure that, and at the end, like this core module should be like only 10% of the size. So the way how you can do that is Android Studio. I will just like add a quick screenshot. It will be all in references. I don't know how visible it is, but there is a feature called analyze dependencies. Probably many people know that. If you don't know it, definitely try it out. It will kind of show you what your modules depend on and exactly on what. So the output looks something like that. Like you see like the users module depends on these modules and exactly on what. So for example, if you see there is just one class depending, and you are depending on a module which has 10,000 lines, maybe it's worth to actually break these connections because you literally have like one small string touching these modules together. There is one more thing, which is backwards dependencies, which is basically the same, but it shows you who depends on you. So this is a typical case for the core. So you want to see like how much modules depend on you and on which percentage, for example. So what you can do is you run this thing. It can take a while, so this is not a cheap operation because it kind of scans your whole project. But after you get that, you will see like some modules literally depend just on one class. So this can be a good indicator. It's like, okay, we need to split this. Like the core has too much, it's basically aggregating too many classes. Features typically need just 1 or 2 to be shared. So definitely try it out if you haven't yet. And something about the betweenness centrality. So this is a dependency hub. Like, what does it mean? It's like the typical case, like you depend on many things, and many things depend on you. So this is kind of like so-called bad module, let's say. Like at the moment you see this in your dependency graph, this is typically like a bottleneck. It's literally like a definition of bottleneck. If you look into that, like a lot of flow goes in, a lot of flow goes out. So this is something like which should be avoided. And you can actually find these. Like, of course, you can like scan the graph, but still the graph is very complex. So you can find this dependency hub by something called betweenness centrality. Here I would like reference you. There's a great talk from Siggy Johnson from Tinder, which is focusing mostly on this feature. And there is a software called Gephi, which can help you with that. So I'm here mostly just sharing, so you know something like this exists. But it can automatically point you. It's like, okay, these are the bad modules. These are your bottlenecks. This is where you can start focusing. So let's go to traps and solutions. So what actually typically makes our module bad? Like, I'm sure I will not cover everything, and I'm curious if you have some examples, but there is many kind of common problems which happen with modularization. So too many modules. Like, I will keep saying that, like, know why you're modularizing. Modules have a cost, and therefore they should have a purpose. If you modularize just because, it's one of the most common things. Like, you come to a small project, it has 50 modules for 10,000 lines. Some modules have one file. You are actually getting negative value from that. So please, don't do that, right? Like, know why you are actually modularizing. What is the purpose of the module? They need to have a value because they have a cost. They are not for free. R-class. This is an interesting one. I will show some details because we got actually massive builds, first failures and then improvements just because of an R-class. Buckets, one place for all. So this is one of the most common one. Like, there is this kind of urgency. It's like, okay, we want to have one place, and then we find everything there. So this is kind of like the biggest enemy of modularization, because then you have one module which aggregates 20 features, and then this module depends on everything, and basically you are kind of losing all the benefits. List-like graphs, we've shown that dependency hubs, it keeps happening. Like, I recommend you just like try to generate your module graph. You will see the red line. Quite often you can find out that your module graph is actually a list, even if it looks very complex. But we've seen many times that we actually had a list. We didn't really have a graph. And then you are losing all the benefits you are actually after. Testing is like a separate topic. There could be just a talk about modularization on testing. You can treat, like, you should treat testing modularization the same as you treat your production code. Like, it could be a separate module type if you have some of your rules, but what also typically happens, like, tests depend on everything suddenly, and then your tests actually build forever. So there are ways how to actually avoid it. So I'm just mentioning it here, like, testing is not like a second citizen, it's actually a first citizen when it comes to modularization. And modularization scope creep. So we did a research. We basically sent a survey, like, what is modularization for you? Just in this conference, we had at least 3 talks, which were called modularization somehow. We got like 25 different definitions of what modularization is. So it's very important to actually clarify why are you doing it, what is your goal. And in our case, it's like, okay, modularization means optimizing the dependency graph, and then other things can build on top of that. Because otherwise, you can end up in an endless discussion. It's like, yeah, we want to improve quality, we want to improve observability, many different topics. So we literally had 25 definitions of modularization. We had to agree on one. So too many modules. So why I keep repeating that modules are not for free. So we did some measurements, which were actually run on M1 machines, which are probably the most powerful one you can get right now. We've seen like 100, 400 milliseconds build time cost per module. And now I'm not talking about the build of a module. I'm actually talking like up-to-date check, like it does nothing. It just exists in a project. But Gradle needs to do some check even to verify that there is nothing to do. So there is a cost. Like, quite often this cost can be paid in parallel, but we've seen builds which were like 5%, 10% slower just because they had modules, too many modules basically. Gradeless sync, that's another thing. Like, this cost is also even bigger. So you can just try to add empty modules in your project. Your gradeless sync will suddenly be longer. So if you have 500 modules, I can imagine like you might have a big problem with Android Studio or even less. Just another argument why maybe have less of them. So yeah. This is like one of the points I keep trying to make, like, module needs to justify its cost. Like, don't have a modules just because. Try to understand, okay, why we have this one. Actually, the most frequent discussion we have with engineers is like, can you merge modules? Because like quite often people have too many. So I'm really trying to emphasize. So one thing we've seen, like, we actually seen 600 megabytes of build data. Like, at the moment you build Gradle, you have the build at the top of the module. We at some point basically exhausted our CI. Basically, we started having like, okay, we are running out of space. Why? On 20 gigabytes machine. And then we find out the cause was a modularization and a bad module graph, because as you go up the graph, it accumulates all the dependencies. There are copies created. Because of the bad module graph, we had like enormous amount of storage used. And the same happens on your local machine. So you imagine like generating 10 gigabytes of data as part of the build is a lot of I/O. It's a lot of like build time cost. So this is also why we focus on like having less modules and having like their purpose and having them especially in a proper module graph. And large modules without dependence are fine. So quite often people are scared at the moment they see like 5,000 lines or more. We say even 10,000, 20,000 lines per module, it's okay as long as nobody depends on them. So if you are kind of moving to that world where nobody depends on the implementation modules on the top level, it's actually fine. If you work on them, incremental compilation is fast. If you don't work on them, they are cached. So quite often, again, the conversation is like, can we merge these? It's like, oh yeah, but they will be too big. Not really. Like 10,000 is completely fine, even 20,000 lines. Actually, quite often we got benefit from merging multiple modules. And the graph became simpler, the whole project became simpler. So continuing the case of the R class. So this one is an interesting one. So the R class is with us from the beginning of Android. What happens there is R class accumulates as you go up the graph by default. There is a way how to avoid it, but by default it like kind of like accumulates all the R classes from all the dependent modules. We actually seen 50 megabyte size R class. It sounds insane, but at the end, like for example, when you use appcompat has some resources. They have 100 kilobytes approximately. If you have 50 modules, you create 50 copies of this. Of course, you have some other dependencies. You have all your own resources. Then one module depends on 50, 100 modules. You might end up with, I don't know, hundreds of copies of resources of appcompat. So we literally seen this. Obviously, it was a big problem for a lot of I/O, slow build times, and absolutely unnecessary to have something like that. There is a setting for it for a while. So if you know it, it's great. If you don't know it, I would recommend it as a first action from this talk. It's like just try to enable it, try to make it compile, because obviously it brings some trade-offs. But this was actually like such a simple setting, can improve your build times, can improve your separation, and testing especially. So test build is highly connected with the R class. For us, it was actually contributing like 5% of the upsize, even if there is minification, even if there were some like R8 running, we still like kind of just by enabling this like shaved 1 megabyte of our upsize. And it was also interesting in one project, we've seen like a slow startup time, because as these R classes accumulate, they might become really huge, and then class loading can be really slow. So if you load all classes or R classes at a startup, you can actually slow down user experience. So non-transitive is a way here. Again, you don't have this problem if you don't modularize, but at the moment you start, this will start popping up. One place for multiple features. So there is like, this is like a very common case. So we have feature flags, app startup, login, logout, all these routines, they kind of require multiple modules to contribute. Like you want to clean up storage. If you have HTTP headers, you want multiple modules, like location module wants to submit location headers. Then you have some other modules like providing session ID, many things like that. And they need to all contribute to one place. So deep links, another case, or navigation, right? So like, this is like many cases where you kind of, okay, so how am I going to solve it? I will have a module which will kind of aggregate everything together. And here we start having dependency hubs. Here we start having like basically our graph becomes problematic, bottlenecks arise. So one way how to solve it is something called plugin approach. Like don't get scared by this graph. It's actually very simple. But at the end, it's a glorified collection. Like plugin is at the end a collection. So the way how it works is there is an interface. If you think about login logout case, you can have a method on login, on logout. And then modules implement this interface, config will implement its own implementation, users will implement its own, and then it comes to a collection. So someone owns that collection and then just iterates through it. Like the benefit through that is the modules actually don't depend on each other. And if you want to add or remove module, the element is either is or is not in a collection. Then there is just a for each which runs through everything. So it sounds like very fancy like plugin, but at the end it's really like contribution to the collection. Dagger can help you with multi-binding, but you can also have like a different ways how to do that. Like important thing here is testing, because the app should in theory work when the elements are not in collection, which means if you have a bug, and we had several of these, where the element was actually not in a collection, the app got released, and then some functionality was not working. Some libraries were not initialized, for example. But it's a very powerful concept, like how you can actually decouple modules. There is many use cases we've seen before, like how to actually split by using this kind of approach. So the last topic, so how we actually impact the business. So like modularization is not cheap. Like modularization takes engineering time, which especially nowadays is the most precious thing, is the most precious asset of a tech company. Like you really need to like think where you're gonna spend your time. Like you can spend 1 month modularizing, or you can develop a new feature which will give you more revenue. So we somehow need to have this in mind if we want to, let's say, be better supported. Of course, like you can do it even without it, but at the moment you have the support of a business and you convince your leadership, you can actually like properly invest resources. So for us, this was actually a key part because you have like multiple different opinions. It's like, okay, we shouldn't modularize, we should just have a monolith, we'll be faster. So it's really important to actually prove that what we are talking about here, it actually brings some business value, however difficult it is. So you can take it as an investment. So at the moment, you say, okay, so we will spend one team 3 months on modularization. The cost is quite high, so we should like justify that investment. So it kind of, again, doubling down is just don't just do modularization just because, like try to have some goals. We can tackle build time, we can tackle collaboration. So one, say, measurable impact is the build time impact. It's like it's the easiest one you can have because it's kind of, yeah, the variable is time. We just want to improve build times, which means engineering time. So we've seen like 33 to 70% local build reduction, and this is purely modularization. So all the optimizations of build time, there are many other things. Like you can have caching, you can have like some local optimizations. So all these can have bigger impact, but this is purely modularization. So we did some experiments, and we kind of proved that, yeah, if you modularize like that by optimizing your graph, you will get that much impact, which you can translate to engineering time together with the CI. So CI is the similar case. Just by modularization, we got like 50% reduction on, let's say, a medium-sized project. And then engineers build more. So this is another observation. So you can like show, okay, look, we actually decrease the build time, engineers build more. You can somehow correlate it with delivery. Like you can say, okay, so we actually, as a business, are able to deliver faster. So what we measured, again, medium-sized project, 50 direct hours improvement in local build time. So you can see, and purely on modularization. So again, I'm not talking about like all the build time improvements, but purely modularization impact. This is direct saving. Then we can start talking about things like context switch. If you have a long build, you typically check emails or something like that. Then you can spend way more time. So if you will try to put some multiplier there, you can achieve way, way bigger numbers if you want to convince someone like why it's important. Another is the collaboration impact. So the hypothesis is like if you modularize properly, like you're scaled properly, your teams will be more effective because they can focus just within a module. This is one of the motivations behind modularizations. So this is the hypothesis. So what we measured is our pull request funnel or change request, whatever system you use, was 25% faster for these contributions when you have just one module. So basically we proved that, okay, we really believe that if you just within your module, it kind of makes sense. If you are within your module, you are faster, you are more familiar with the code, you are not stepping up on anyone, you should deliver faster. So what we also measured is like the kind of percentage of the modules which touch only a single module, because you can basically use GitHub API in our case, you can just dump it into analytics or even in spreadsheet. You can do actually amazing things by spreadsheets. So you can actually analyze like how people are contributing. And then as the modularization evolves, like basically what we've seen, like again, 50 hours a month saving because we kind of increase the percentage of the single module pull requests. So we've seen like engineers more often are, when they deliver, they can just focus on their module. They don't have to go across many modules because the code is better separated. So this is something how you can measure the collaboration impact. And then once more, the business impact. So we kind of got 100 hours a month direct saving. So this is something already you can start, like, okay, so if we get this saving per year, you can translate it maybe in like 2-3 months of some small team doing on modularization. So you can really do some trade-off with the clear numbers with the business. Like then another hundreds indirect. So this is also important. Like it's not like we cannot justify everything by hard numbers. It definitely helps if we justify something, but there are another 100 hours which are indirect. We can start talking about cost of context switch, different things. The collaboration can be more expanded. So there is a lot of saving and then scaling. So what we've seen, like basically at Glovo, where I'm from, we seen the app code increased by 50% every year, which means the code base doubled every 2 years. And this was consistent across 4 different apps, so it was not just like one project. Then in one of those 4 projects, we actually got into the kind of desired state of modularization, so this stopped. So all the other projects kept growing, while this one stopped exponentially growing. It slowed down significantly. The hypothesis behind that is we were actually able to more target the contributions. We were able to delete that code. It was more clear who owns what, and we were basically able to remove a lot of code which was unused. You can do it again without modularization, but it just became easier by that. And ownership, and this is like also a big one, because especially if we talk about modularization, you typically are in a large code base between multiple teams. I don't know what's your experience, like mine is, then it's really hard to do something across 10 teams, across 20 teams. Like if you want to migrate from one library to another, it can be a nightmare. Typically you can end up with both as a result. So for us, like what we see right now, like the biggest benefit is like, okay, we want to migrate from Dagger Android into Hilt, for example. Then we can say, okay, we have 50 modules using Dagger Android. We need to migrate 50 modules to Hilt. What does it mean? Like we have a progress bar which has 50 modules, and we can go one by one, and you can assign owner, because the team, like, it's a clear owner who actually owns the module. So we see that working really well. We are powering multiple projects by that. So it's also a big enabler for any initiative you have across the app. So now what? So we spent some time together. Thank you very much for that. So what you can take from here? So clarify why you want to modularize. It's like, I can't stress more how important this is. Because if you modularize just because, like, you might spend a lot of time, and at the end nobody will be happy because you will not get the real benefits, your project will be more complex, and you will spend a lot of time basically, modularizing, but that will be it. So clarify why you actually want to do that. Like, is build time your problem? Let's focus on build time, let's measure that. Visualize your modules. I'll be sharing references how to do that. Like, you can do it just now. You can start reasoning. It's like, okay, like, is our graph, are we happy with that or not? Define rules and assert on them. You can write like super simple script how to do that, or I'll be sharing a plugin which can do that for you. It's a simple thing. Maybe you already have something like that. I assume if you're interested in modularization, there is some idea. It's like, this is the structure we want our application to have. And then, then you can start scaling your product. Like, and then, you can prove business value, measure. You can see like what actually you are getting, or maybe you are not getting what you were hoping for, and maybe you can actually simplify some modules, merges, etc. And then tell others about it. So modularization is with us for a while, but it still kind of isn't solved fully. Like Google released some documentation just 2 months ago, and let's say we talk about modularization maybe 10 years already. So this is just another proof. Like, it's still like not fully unsolved topic. You have many different approaches. So it's still worth talking about it. Like, I'm super happy if you approach me, if you talk to me. I'll be interested in like how you modularize, like what we can learn from each other. And because it's the last talk of the day, I think, so we can go to a party. And by that, thank you.